Me clearly? Okay, can you hear my voice? Okay, if you need the QR code, later I will show you in the middle of the class, okay? So let me show you the okay, let me show you the GeoGebra. Okay. Um, I hope you try this at least at home. Okay. Try to make some functions and see the how it will work. Okay. And also, um, if you want to make more than one variable, for example, um, let's define our function to be x and y. For example, this is just an illustration. So if you want to have x sine y uh, plus cos x, if you just make these functions two variables, if you are still using the two-dimensional like this one, it will not generate any graphs. Okay? So if you want to see clearly what is happening, you go for the 3D graphics. So you can see here like that one. This is in case you are curious to see what the graphs looks like. So the GeoGebra, they can also recreate graphs in at least two variables. Okay? Okay, this semester we will at least two variables, but most of the methods we will use only one variable. Okay? So I think for two and more variables, you will see in the next semester calculus. Okay? So you will see the differentials, partial derivative, and so on in the next semester. But in this semester, at least you will have at most is two, but it is just a few examples. Okay? A few examples. This is just illustrations. If you want to see the graphs, okay, if you want to see the graphs, you can do it in GeoGebra. And also, let me go to the GeoGebra one more time. Let me. So if you see GeoGebra as a website, you can check classroom resource. Let's just say calculus. Okay, see if they have some resource about calculus. So they have some resource about calculus like this one. Okay. We can see some examples. Okay, depending on which topics you want to read. Okay. Let's just say, because all of this is, you see, this is the activity. Activity means it's only one event, so it's only one graph and one activity. But if you see like this book, which means it has several activities. So let's try to see the books. Okay. Here, at least most of the chapters in your calculus will be already here. So if you want to see more illustrations, more graphics, how to deal with some graphic situations. For example, let's see our derivative. Okay, so you can have several topics. Okay, several topics that some of the topics I already mentioned. And we can see from here, for example, okay, you can change the point here. You can change the this age. Okay, remember the age as in the limit, the delta, right? And then you can also change the number as you want. Okay, and you can see, like, for example, the intro for the derivative, and you can also see the change of the tangent. Okay, let me make it bigger. Okay, so every time the point moves, okay, the tangent is changing. Okay, and you see when exactly at uh, at that point, okay, it is in the x equals 0 in that graph, your tangent becomes horizontal, which is the gradient is 0. Okay, that is. I think this is if you cannot imagine in your mind how the graph looks like. Sometimes you can take a look at graphs, and in GeoGebra there's a lot of tools that you can take a look. Okay, a lot of people already built some activity that you can just click and read. Okay, and if you want, you can also create your own graphs and see what happened, okay, when you are solving your limit, solving your derivative. Um, I think some problems in calculus, it's way better if you can imagine the visuals. Okay, the visuals. It's way more easier to understand instead of some notations, formula, and some definitions. I think that's sometimes it's more. Um, it's not really clear what does it mean. But if you see the graphs, you can see clearly the point, the x, y, and you can see um, the point when it's changing, the tangent also changing. Okay, and also um, in this case, you can also change the whole function. You can recreate your own functions. Okay, um, let's just say sine, and we can also move our sine. Okay, so every time it's reaching the maximum and minimum value, the gradient is, it tends to be 0, but you will see the graphs, it will not be horizontal. Okay, that is our case in sine x over x. Okay, okay. Um, okay, I think that's just introduction for GeoGebra. So if you want, okay, if you want to look around and maybe review some parts of our class with some graphs, I think that's a really, really good tool. Because when I was in undergraduate, like you, uh, before then, social media is not around. Internet is like early introductions, and a few page we can browsing some information, but it's not like today. Today is like you have a lot of information, but today's problem is because there's a lot of information you can find in the internet, okay, especially from any website, right? When you have a lot of information, it's difficult to transform that information into something knowledgeable, or how to transform those information into knowledge is difficult. That's, I think, today's most of undergraduates' problem. They have all the tools, they have all the information, but they cannot transform those information into knowledge. Okay, so I want to encourage you. Okay, you need to be first. You need to be independent. Okay, do not uh, do not depend on your friend. Do not depend on your PA. Do not depend also on your professor. Okay, you need to depends on yourself. That's the key point. So you need to learn by yourself, because everyone, I believe, you have different way to learn. Okay, and I want you to find your own way to learn, because I cannot enforce you to be like all the same. It's really difficult because everyone has their own way. Okay? And in calculus, I will explain to you some methods, some tools, applications, and so on. And to solve some problem in calculus, sometimes you have several ways, and I I give you like, if you want to choose your own way, like it's correct in calculus, it's mathematically correct, it's logic, then that's fine for me. Okay, so that's the first part, and then let me. And then, before we go to our topics today, next week, next week, next week, Tuesday, quiz. Okay, quiz from the chapter 1, functions. It's all about the functions, domain, maybe how to transform your functions, new and old functions, and also the chapter 2 about limits. Okay, from introduction of limits, limits at infinity, infinite limits, and so on and so forth. Okay, it will be only 30, maximum 40 minutes. Okay, 30 to 40 minutes. Okay, so you will have quiz first, and then we have class after that. Maybe around six, or maybe around six questions, around 6 questions, or maybe less, maybe less. It depends. Okay, and also for the online students, I will give you some technical procedure for the quiz, because you are still not in the class. Some of you are still in quarantine. I will give you in details in the Moodle system, so please check the Moodle system. Okay, we going back to our discussion here. So we are discussing the product rule. Okay, so every time you are proving any rules in derivative, you need to start with this form. Start with this form. This is by definitions. Okay, this limit form is definition of derivative. So derivative is limit as h going 0, or there are another form you can also use. Let me write here. This is also you can use. Depends on the occasions. But if you want to use this part, I think you can, but you need to rewrite some forms. Okay, so in some cases, it's better to write in this, like having a like h as the distance, or x minus a as a distance. It depends also. Okay, we have discussed this problem before. So product rule. So the function is fg. So you are changing all the f with fg. Okay, so this big f is okay. Changing all, and then why we need to add and subtract this form. Okay, because it's a little bit tricky, but the idea is you have 1, 2, 3, 4 expression, right? So the idea is to have a grouping from this expression 1 and expression 3. Why? Because it has the negative sign. If you see any negative signs, okay, maybe you can think that the negative sign will make this form similar to this form that you can transform. Okay? So when you are grouping this 1 and 3, it becomes this. So you factorize fx plus h, and it's become gx plus h minus gx over h. And this whole form will be the g prime. Okay? Same thing here with expression 2 and expression 4. It's plus and minus. That's the whole idea about the product rule. Okay? And I believe we are still writing the quotient rule. Okay, this is just a review of last week. So our quotient rule. So still, we are grouping this part. Okay, and we are looking for what? For the other minus. So this minus here, because this is gx, this is gx, this is plus, this is negative. Let's combine these two together. Let me write with blue color. So fx plus h minus fx. And then I will skip some process. This h I will bring back to up here. So it's become like all will divide by h here. Okay. So I will make this appear h here. And then minus the group 2, okay, is the fx. Okay. This part. So I will start from this gx plus h because it has negative fx, okay, and then minus fx, gx, sorry. Okay, and then all the expression divided by gx plus h and g. And let me copy all the forms here. Okay, let me copy it here first. Okay, and then we are evaluating the limit. So limit h0 and all is divided by, I'll just limit. Okay, so see from here, this is just g of x, okay, and this part will be f prime x, right? And this is just f of x, and this part will be g prime x. And the whole part at the bottom become gx and squared. So you can write the total derivative for the all these definitions will be, I will write the f prime first, okay, because it's easier to relate with the product rule. or you want to keep running? Okay, they have this expression as your quotient rule. Okay, so I prefer to write the f prime at the first terms here. Like for example, the product rule is plus, right? So this is just my suggestions. So you can make similar expressions, okay, f prime, but the difference is you have negative here, but positive in the product rule. Okay. This is for f over g. This is product rule. Yeah, just some suggestions to help you um, remembering all those formulas. But yeah, okay. Um, any questions? Any questions? I think I will go for some examples and go for. I think we're going to go for some basic trigonometry and some examples. Okay. Okay. If there's no question, so I will continue for the example. Okay. Uh, so for this example, I need to know whether you know the find the equation of tangent line and normal line. To the curve uh, y at 1.5. So you need to find, the question is just asking the tangent line and normal line. And this is your curve, y equals curve of x over 1 plus x squared. And this is the point, 1.5, x, y. So first, uh, read the question first, okay? Do you understand the question? So that's the thing that you need to be aware of. Okay? Do you understand the questions? You understand the questions or not? Find the equation of tangent line. So you have curve y equals square root of x over 1 plus x squared. So that's your curve. What you need to find is at every point of the curve, your tangent line can be changing, right? But at that point, the question is asking at point 1.5, you need to discover the tangent line, meaning you need to find the linear equations of that tangent line. Okay. Okay, this type of questions, asking the tangent line, normal line, and so on and so forth, uh, it's typical that it will be around until your second calculus, until the next semester. This type of question will be similarly asking. So you will find in the problems, maybe in chapter 10, 11, uh, they will ask the same similar questions. But the idea for how to solve is pretty much the same. You try to find. Okay. Okay. First, we need to make sure that uh, you know what the tangent means. Okay. So tangent means the gradient or dy dx. Okay. Meaning this is the first derivative. So your y. So you need to find your y prime or dy dx. And because we already learned the quotient rule, let's just use the quotient rule directly. This is f prime. Okay. Okay. And also, the important point in finding tangent line or normal line, if you just get this expression here, because it's already specified the point is on at x equal 1. And if you think it's easy enough to be calculated here, then just plug in the point 1 and you get the gradient. Okay. Um, because sometimes when you are in the maybe quiz exam, I find a lot of students, they try to simplify this form first, and then they plug in the number. They are wasting the time to simplify because it's not what the question asks. The question is asking the gradient, right? The first derivative of the of this curve. Okay? So if you find the number is easy to be calculated, then just plug in and you get the number, right? So let's just plug in the number. It's negative 1 over 4. Okay, another point that I want to make sure that you know, okay, this is the tangent. Okay, let me write this is the tangent. The normal is, if the tangent is m, the normal is negative 1 over m. The normal will be 4 in this case. So you have negative 1 over 4 and normal is 4. And for the equations, you can just use the either this part or you can use this equation. The uh, same results. And then the other one, and this is the line that you want to find. Okay. This is the tangent line. This is the normal line. Okay. But I think that's a simple example. Okay. At least for now, my suggestion is try to understand the questions. Okay. Especially if the problem they have a lot of terms that maybe you are not familiar, and then you need to find the meaning first. Okay. Find the meaning, and yeah, you get the results. Okay. Um, let's move to the basic trigonometry. I want to prove the if you have a functions sine x. Okay. You know that the first derivative is what is cos, right? But let's try use our definition to prove. Okay, this is our definitions. So write all in sine x plus h, and then change all to sine. Okay. Anyone remember what is the formula for sine x plus h? Like alpha plus beta, like maybe in your high school. Remember the formula? Sine sine cos cos, or sine cos cos sine. Remember? Yeah, that was sometimes you mix with the cos. It's sine cos, right? Sine cos cos sine. Sine cos plus cos x sine, and then minus sine x. Divide all with h. Okay. Let's grouping the sine x. Okay. And let me separate, become two parts. So first this part, second is this part. Okay. I'm not sure I already gave the explanation to you or not, but uh, anyone know this limit? You have cos h minus 1 over h, limit as h approaching 0. I haven't told you, right? Haven't? Okay. Let me write with the red color. Yeah. So this is notes. Okay, notes. So if you have limit, let's just say x approaching 0, cos x minus 1 x. Okay. Remember that we have proven that when you have sine x over x, it's 1. Okay. Remember this. So for this part, I will multiply with So it will be cos squared x minus 1 x. A little bit tricky here. Okay, I will remove the negative to the outside, and it will be 1. Oh, wait, it's x cos x. Right? Okay. This whole part becomes sine squared x. Okay. Remember, you still have negative sign here. I will separate become 2 sine x over x and sine x over cos x plus 1. Okay. Use limit on both cases. Okay. This whole part becomes negative 1. Okay. This one becomes 0, right? Sine x, sine 0 is 0. Cos 0 is 1, so 0 over 2 is 0, right? And negative 1 multiplied with 0 is 0, right? Okay, 0. Okay, so this whole part is 0. So this is sine x. Sine x with 0 is 0. So we are just having this part left. Okay. So let's write the limit h 0 cos x sine h cos x plus okay. This part is just cos x, okay, because you cannot find any h in cos x. This part is 1, right? Sine h is 1. So that's why if you have the function sine x, your first derivative is cos x. It's the same similar method. If you are having the cos x, then your first derivative is negative sine x. The negative is from the cos x plus h. You will have the negative sign, so it will be negative. But the concept is all the same with the sign. Okay. Am I too fast? Is it too fast? No? Okay. Too fast? Okay, okay, okay. Okay. Let me a little bit repeat this part, okay? So from here, okay? So from here, I'm grouping the sine x here. And then I will one by one evaluating the limit. Okay? So first limit h0 for sine x here. Okay? And second is this part. Okay? But because this part, we are not sure what will happen, we can actually redesign, or we can rewrite the form f cos x, because if you plug in 0, it will be 1 minus 1 0 over 0, right? It's indeterminate form, and any limit doesn't like that form, right? That's why I try to rationalize the form by multiplying this cos x minus 1 with cos x plus 1 over cos x plus 1. Okay. The idea why I need to multiply this is because this whole thing here. Wait, a little bit delay. Let me make the. Okay, let me make the new one. And present. Okay. So we're evaluating all, okay, become sine x. And this part going here, multiplying this. Okay, this is the reason. I want to find this of y. Okay. So I want to find the a squared minus b squared situations. And then solving those part. Okay. Okay. So solving those part, I got this equations. Okay. This equation I can rewrite factoring the negative parts outside and making the 1 minus cos squared b, and it becomes sine squared. And then you can solve it with the help of the sine x over x here. So you have sine x squared. I'm separating the sine squared, becomes sine x sine x. I'm separating x and this cos x plus 1. So I have these two expression. Using limit each one, this part become 1 and just negative 1. And this part become this 0. This become 1 plus 1, 2. So 0 over 2 is 0. So this whole part will become 0. Okay. 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 Maybe some basic derivative for trigonometry. So you know this first, and the second one. Similarly, you will find this is secant squared x, and then secant x, secant x, tangent x. There's also another like cosecant, 1 over sine, right? And cotangent 1 over tangent. But I think this 4 is useful. Okay, this 2 is not really frequent happening. Okay, that's trigonometry. Let me go one more to chain rule. Okay, so you can have a basic for derivatives. So you already have the product rule, quotient rule, and so on. The power rule, of course, and then the trigonometry, and also the now we'll have the chain rule, and we will have some review, a little bit review, and some examples And later, maybe next Thursday, I can go for maybe exponential or logarithm. But if you still have time, I will maybe go for exponential today. But I think we can go just for chain rule and some overview of the examples. Okay, chain rule. Is chain rule already been taught in high school? I forgot because I forgot. Have you learned before chain rule in high school? Not remember. Remember? A little, right? A little. Okay, chain rule. Basically, chain rule. If you remember uh, remember this or f, okay? It's called the composite function. Composite function. So what composite function means is if you have this FOG, you have gx inside the f, right? Or in this case, g. Wait, it's a little bit delayed. So what chain rule means is when you are trying to solve the composite, the combination, more than one functions inside, like the function is inside the function, and maybe that those function inside of another function, then we need to find or we need to define a way or rule to set up the definitions. So for example, if you want to derive this composite, they want to derive the f with gx at the inside. Okay, we can say that this is the um, f prime gx. Okay, and we need to multiply with the g prime of x. That is what is we are doing in the chain rule. Basically, that is what we are doing. Okay, so this is one example. Okay, and it can be um, repetitive. Okay, for example, if you're gx, you have another function inside gx. You can have a lot of multiplications. Okay, and sometimes you are forgetting this g prime. Okay, so right here, don't forget this part. And another way um, to write this composite, you can write, for example, if your function inside is a variable, let's say a, okay, you can write this as you derive the whole composite with a, okay, and because a is another function of x, you have to multiply with dA over dx. Okay, that is how you read this part and turn into the, okay. So we can also write uh, d gx, and this is y, and this is d and gx x. Okay, okay. It's the same thing. But if you are preferring to write in one variable exactly a or u or v, then you can imagine the gx is a variable a. So you derive the whole function here with the gx. Okay. So for example, let's see. Okay. For example, if you have your y is sine x and squared. Okay. What does this equation means? You have a sine x, okay, a function of sine x, okay, and then you have some function, let's say a squared. Okay, you have two functions. So the first function is sine x, which is the inside, and then the outside functions is the a squared. So you can think of uh, this is the red color here is your outside function, and this one is inner function. You can also think like outside and inner function. You can also think the chain rule as like that. So it has a several way to interpret or to understand the chain rule. You can understand the chain rule. So you have from the composite of point of view, you have composite of f of g, which means when you derive this, you derive the whole function, the f, okay, and you don't need to change anything inside because it's still inside the f, right? But you need to multiply with the derivative of this inside e prime. Or you can write uh, in these notes, okay, in Leibniz notes, dy dx is dy over if this is g is, for example, it's just a, let's just say dA and then dA over dx. Okay. This is a general way or general point of view to understand the chain rule. Okay, but if you are already familiar and you can directly approach the equations and you can derive easily, then just derive directly. That's fine. But if you are thinking the function is too complex or too complicated, then you can you can make each functions. You try to find each derivative, and then later you can combine at the end. You can view several way to solve. Okay. So for example, in here, this is becoming cos x, right? And this becoming 2a. So you can just directly go 2 sine x and then cos x. You can go directly like that because it's not too complicated. So you just derive the whole functions and then multiply by the inside function, the derivative of the inside function. And then you get directly the answer. Or if you want to be more careful when you are calculating, if you want to make sure that your step is correct, you can just view as several functions, derive each one, and then combine at the end. It's the same thing. Okay? It's the same thing. Okay. Okay. Um, okay. And don't forget that because this is a composite function. Okay. Composite means you have a functions inside a functions, maybe inside a function and inside a function, maybe a several functions. That's possible. It's different from you have for example, you have f of x and g of x. Okay, this one, okay, this one is the product rule. Okay, remember, it's not the same as the f dx. Okay, it's not the same thing. Okay. Okay. Let me show you several, maybe a little bit practice. If you have y is let me just go like for really understandable approach. Okay, this is also easy equation. It's not too complicated. It has, I think, two functions. Okay, this 5 minus 6x. Okay, and then this part powered by 5 is the second function. So the first function is this inside function, and then the second part is the outside. Okay, you can view, because this is the outside functions, you can view this as when you derive like x5, okay, like x to the 5. If you derive this, then you have 5x4, right? So it's the same thing, 5, 5 minus 6x, and 4, okay? But the second function is your g inside. So this is your f, and this is your g. So we'll write this, okay? It's g, this is f. And then just multiply with the inside functions here. Derivative of the inside function is negative 6. So your whole function will be negative 30, 5 minus 6x with the power of 4. And this is the answer. Yeah. You can go like each example, like for example, like this is the first example, and then the second is the uh, ddx of 5 minus 6x is just minus 6. Let me go one more example. Let me go for the 3x squared minus x. You can think of like from previous example, you can think of this is just a like that, and then you have 3x squared minus x. And this, if you want to find the derivative, this is become this part, okay? And this one becomes 6x minus 1. So you combine these two. So 6x minus 1 over 2. A is the 3x squared minus x. Okay. So anyway, you are solving the chain rule. As long as the definition is correct, and you will be fine. And you can feel like you can make these two functions first and then combine at the end, or just directly go for like for example this one. Okay, you have this is power of 5. You just directly use power rule 5 and 4 and multiply by the derivative of the inside function, and that's it. Okay, it can have more than like this example is only have like f and g, but it can also have like h and all and other function as well. So for example, you can have to dy dx. Okay, maybe you're using u, du, maybe dv, and maybe dv, and maybe dw, and maybe dw dx. It can also possible to have like this more than two functions. So this is two functions, and this is like you have at least 1, 2, 3, 4 functions. So it's like f, g, maybe h. So the function inside the function inside the function inside the function. That's also possible. Also possible. But please do remember this form. Okay. because this will be useful for your next calculus, next semester calculus, and also for your engineering mathematics. You will also learn, or you will see these forms more and more. Okay. 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 I will go for several examples, and I will have you try the examples. Okay. But before that, any questions first? Any questions? Okay. I think all the examples that I gave, always uh, the easy questions. Let me prepare some words first. Or do you want to have 5 minute breaks first? Do you want or no? Do you want to having break first? Five minutes? Okay. 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 5 minute breaks. Yeah. Which one? Can you check? Okay. Okay. Online students, what do you want to ask? Uh, yeah, the quiz. The quiz. You want to ask about the quiz? So the quiz will be about the functions, um, the limit. Okay. So all before the derivative part. That will be the quiz. It will be 30 minutes quiz, and I will send uh, the information through the Moodle system. Okay. About proofing. Um, I cannot answer whether it will be having a proofing or not, but uh, my advice is just do not memorize the proofing. But remember, because it's only 30 minutes quiz, um, so it will be 5 or 6 questions. If there is a proofing, maybe it's like a short proof, not really that like the sin x over x. I think that's quite long. Okay, let's start. Okay, let's start with just uh, some practice. I have two examples. Okay, so first is this one. Okay, find equation of tangent lines. Okay, so tangent line from the curve. That's the curve, and the tangent line is parallel to the equation 3x minus y equal 15. Okay. So do you know parallel means? Do you know parallel means? Okay. So parallel means it's having the same gradient. Okay. So parallel and also perpendicular. It also the terms that frequently appear in exercise. Okay. So maybe what I suggest to you. Okay. Uh, if you don't really understand the terms in English, okay, you study the terms first. Okay, what does it mean from the PDF file of the exercise? Okay, you see the questions. Make sure uh, I'm not expecting you are uh, learning all the exercise or studying all the practice, but at least when you see the questions, you know what the questions means. Like you understand what the question is. So this is the equation of tangent line from this curve. Okay. So fx, x, this is cube. Okay. X cubed minus 3x squared plus 3x minus 3 is parallel to line 3x minus y equal 15. Okay. So from previously, we know that if we want to find the tangent line, we need to derive the curve, okay, to find the first derivative. So let's try to find the first derivative. Okay, I got this. Okay, and it's parallel to line. So let's fix this into y equal 3x minus 15. Okay, so you see here it has the gradient of 3. Okay. But what else do we need to find? Okay, remember that when you want to make a tangent line, at least you need to know the x and y, the position, okay? The position. So because you already know the gradient is 3, so you need to find another gradient, and you need to find the positions. Okay, what you can do here from your derivative, you can find the solution for x. Okay, you find the solution for x. Find solution for x. You can write this as, oh wait, it's not 0, right? Should be our gradient. and this 1. You fine? Okay. So you have x is 2 or x is 0. Try these two to our, so find the f2, find the f0. This is your y, okay? Check your y. And then you will have two equations, okay, from here. So let me just write this 2. It is 3. It's -1, right? -1, right? So first is y plus 1, 3x. Second will be y plus 3, 3x. You can solve this. You have two equations. Okay, I think this is also a simple, not really complex, not really complicated. Okay. The next questions after this page, I need you to find by yourself. I'll give you maybe 15 minutes to solve. Okay, after this page, and if you finish, please raise your hand. Okay, I'll give you first a bonus point for your score, and also a bonus snacks. Okay, so here's the questions. Okay. Uh, Not this one. Oh, this one. Uh, is it clear? So I will read. Sketch parabolas. You have two parabolas. First is x squared, and then the second one x squared minus 2x plus 2. Two parabolas. Okay. You don't really need to sketch, but you can sketch to give good illustrations if you want. It helps you to solve. The question is, do you think there is a line that is a tangent to both curves? So remember the tangent line? So this tangent is in the two curves. Okay. If so, find the equation of the tangent line. Okay, I'll give you yeah, 15 minutes. Okay. First, maybe you can draw if you want to get some idea. Oh, you have uh, difficult to see, or sometimes like water, like watery. Oh, okay. Yeah, you need to have like a lot of rest because I think maybe from the light and from the computer. Yeah, usually. So do you understand the question? Okay. Well, can you draw this one? This one? Uh-huh. Hmm. Uh-huh. Yeah. Yeah, you need to find when it's the same. Yeah, it may strange, but if you draw, you can find some line. But can you draw this one? Or I have some a simple way to draw this. Okay. So can you make the complete standard form of the square? Yes, 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 yes. And then you can imagine from this part, it's moving to the right 2 points and moving to the y-axis. Right? Yeah. It's practically the same curve, but you are moving the curve. Okay. You okay? Okay. Can you draw this one? Uh-huh. The curve is actually the same, but just move the positions. Yeah, there's funny, right? Remember, a tangent should be at the exact position, right? Is this position the same? Different, right? So if it's 0, maybe this will be some number, right? So this should be not equally same. It's different x, different point. Okay, good, good. Yeah. So you can actually having maybe here. Maybe here is the tangent, right? Maybe this is the point, and this is the point for the this curve. But remember, the tangent or gradient is depends on locations, right? Depends on the x. So your this one, it has different x. So you need to find x1 and x2. Maybe you can start with maybe a, maybe b. Yeah. And you need to find this a and b. Yeah. Yeah, you need to find and use the uh, this is f of b, right? And this is f of a. So you have the dy over dx, right? Fb minus fa and b minus a. Yeah, you can use that. And fa, fb is you have the function here. You can use the function and you have the equations. Yeah. Okay. Okay, okay. Uh, yeah, should be like that, right? Yes. Yeah, yeah. Okay. Can anyone finish? Only one, two. Let's see the answer. I will give you after this. Okay. Yeah, this one is 2x and this is 2x minus 2. Right? Yeah. Yeah, yeah. Yeah, yeah, yeah. Mhm. And mhm. So, do you know the position here? The point here? Do you know the? Yeah, it's almost there. Yeah. So first, you need to think of like if you know this positions, right? You have this triangle. This y over x is also the tangent, right? Do you know this distance and this distance? Yeah, that's the gradient. And you need just to put in the functions. This is the functions, right? This is the y, right? The functions, right? Function of x. Okay. You got it? Yeah, yeah. Almost, almost. let me prepare something first. Okay. Let me check your answer. This one, right? Is it 3? Sure. Okay, okay, okay. You got the equations? Okay. You got the equations? Okay, good. Okay. I think I will just explaining to you. I think one of you got correct answer. Let me just draw first, okay, to see. Okay, so before I draw, maybe you are forgetting how to find. So for this this curve, you cannot find any roots, right? The real roots, right? Because it's not going to the x-axis, right? It's not easy to factorize. So my suggestion is if you find any curve like this and you need to find a simple way to draw. So rather than using the calculators or any website to find the graphs, you can use the this way. So this is the plus 1, right? So this plus 1. So from here, it's actually the same graph as x squared, but you are moving to the right side 1 point and plus to the y point, okay? 1 point to the y. So if your graph of the x squared is like this, okay? So practically what you are doing is moving this part, okay? Going to the maybe 1 here, 1 here. Yeah, it's not good, but yeah. Hope you can get the idea. So the tangent line is here. No. Why it's so bad? Okay, that. Okay, imagine your point is here. Okay. Okay. So from this triangle here, okay, I have this triangle. So if this B is this A, okay, this is B and FB, right? And this A is A f of A, right? Okay, you can see this gradient is also FB minus FA over B minus A. Okay. And you can use the functions from this and this. Okay, this is from B. This is for B. This is for A. Okay, so you can solve the gradient first. Okay, let me just solve this. There's enough time. Okay, so at least you get the idea here, and b minus a here. Okay. And also, because it's the same tangent, so when you try to solve, this is 2x, right? And the other one is 2x minus 2, right? From the second curve. You are thinking, this is not the same, right? Remember, okay? The tangent at every point here, okay, it will be different. So it is better if we say that 2a is equal to b minus 2. So b minus 1 is a. And substitute this to our equations, okay, to the equation. So substitute this b minus 1 to here, okay, and you get some solution. So maybe I will just give you the part. So so this is what we've done before, okay, the gradient, okay. So the gradient 2a, 2b minus 2, it should be the same, and it should be b minus 1, okay. And substitute to the to here, substitute to here, and all these m1, m2, and m3 all have the same value, the same gradient. So you start with the equaling m1, m2, you get this expression. Substitute to there, m3, and you can equaling m3 to m1 or m2. But let me just equaling to 2a. It's much more simple, right? So 2a, so 2, this is a. 2a is equal to this part. Solve this, get the equations. You get the b, you get the a. After you get the b and a, you can plug into the solutions. So the line equation will be the a squared is your y, right? You're from x squared. So a squared 2a x minus a. Substitute all with the a. We get a, it's the half. Substitute with half. It's y minus 1 over 4 equaling x minus half. And then the answer is y is x minus 1 over 4. Okay. I think one student get right. You right? Okay. Also, I will give you snacks. Okay, congratulations. Okay, and happy Moon Festival. Okay, I need your student ID. Okay, after this class. Okay. So, yeah, I think that's it. It's quite complex, but if you think first, if you think you can draw the curve, when the curve is easy to draw, my suggestion is to draw so you can have idea what happens here. Okay, when you get this line, you get the idea of this triangle here. And if you don't know, like you need to know the position, but you don't know, or you don't know the information. So just assume, okay? Assume with A, with B, with x1, x2, up to you. With alpha, beta, it's up to you. But in this case, I'm assuming this A, B, and assuming all these functions here from the information. And from here, we start to get the idea. First is all the value of the tangent should be the same. So when we find the gradient, it should be the same, the same, the same. And we start to solving all this equation, finding A and B, okay, and then use that A or B into our line equation, and we get the answer. Okay? Is it difficult? When you have the process, it's quite easy to understand, right? But when you see at the first time, maybe you feel, oh, it's quite complex. But when you try to solve step by step, you will see the idea of this question. And remember, it seems the questions, the x squared minus 2x plus 2 seems to might be difficult to imagine. But when you making it into standard form in the quadratic functions, you see that it's actually the same function as x squared, the same shape. You just move this functions going up. Okay. Okay. Any questions? Questions? It's okay. This part. Okay. Too fast? No. Okay. Okay. Um, we'll continue next Thursday. So I will stop here. And yeah, see you on next Thursday. We will discuss derivative more on Thursday. Okay, Tong. Okay, you're correct. Yeah, that's good.